All right, we're live. How's it going, Evan? Nice to have you on.
Going well. Nice to be on. Happy to
Thanks.
be close to getting Matcha out. It's been a while.
Yeah, so everyone who's tuning in online, we're just hosting an informal live stream to talk about the Matcha upgrade, which just hit Mocha on testnet, and that means that it's on its way to mainnet. And there are a bunch of really big changes that are coming with the Matcha upgrade. And we're bringing on Evan, who is the lead of our core protocol engineering team, and is the mastermind behind some of the biggest features in Matcha, namely the upgrade to the block sizes. So we'll get all into that. But Evan is also kind of known internally as the Giga Chad. That's his nickname, for good reason. I think you guys will all find out why. But anyway, Evan's been on the team. I mean, he's a founding engineer. He actually joined the team before I did. So he's a true OG. So we're blessed to have him. So anyway, Evan, maybe just give a quick introduction to yourself and how you got into Celestia, and then like what you've been working on the past 4 years, and then we'll dive straight into Matcha.
Sure thing. Like Nick said, I'm the team lead for the core team. So we mainly work on the consensus portion in the application. And lately, that's mainly been focusing on increasing throughput. So this is with the Matcha upgrade, we're trying to increase to 20 megabytes a second. I think it's technically 21.3. So that's what we've mainly been working on recently. I guess over the past my time at Celestia, I've kind of gotten lucky in that I've been able to work on a lot of things. I dabbled slightly in like Celestia Node and Rollkit even, but like all the encoding schemes and everything, and just getting to sit in on like all the long discussions between John, Moose, and Ismail and about random things has been a lot of fun.
Yeah, I think Evan, you're also just a true cypherpunk that believes in and is driven by the core values of crypto and blockchain, self custody, verifiability, and kind of building out like a infrastructure for like human coordination. I guess I don't know. Maybe I'm putting words in your mouth, but I've always seen you as someone who's like deeply committed to the values of crypto. And that's something that's very special. And you really, I feel like, you have like this vision for like what blockchain is about. So anyway, I don't know if you want to talk about that quickly before we jump into all the engineering stuff.
It resonates with me strongly. Yeah, I definitely try sometimes. I guess that's about it. I think a lot of people in Celestia are sort of naturally drawn to that vision. Like I know certainly you are as well.
Mm-hmm.
So yeah, it definitely resonates, and I feel just super fortunate just to have like the ability to work on something you believe in is like makes work a lot easier. That's for sure.
Yeah. Well, thanks for coming on again, and let's actually get into the meat of the this stream, which is the Matcha upgrade, which was announced a couple days ago. Let's talk about like why it's being called the biggest upgrade yet to Celestia. There's a lot of different features that are rolled up into it. Maybe you can give us just a high level highlights of the different CIPs and what they mean for the protocol.
Sure. The headlining CIPs, I forget the numbers, but there's one to increase throughput and transaction size. So that's increasing to 128 megabyte blocks, still at
Holy
6
shit.
seconds.
Did you say 128 megabytes?
128 megabytes.
That's fucking crazy. Maybe put that in context for people, like so they can appreciate how crazy that is. And also, I mean that's still at 6-second block times, correct?
Yeah. The block times are actually getting a lot more
Slightly
precise. That's a separate thing. But the first mainline CIP is 128 megabytes. That's like 16x increase, I think, from the existing throughput.
Yeah. But I mean,
I don't know what
like, that's
else.
just absurd. I don't know if people can
It is
appreciate how absurd
large. Yeah,
the
yeah.
size of that is.
When people, I think one of the biggest criticisms to having like a huge amount of throughput is like, oh well, no one's going to use that, which is like, why do you need 16x throughput? And I don't know. Sometimes I feel like those people lack imagination. Is like you could find ways to fill it up. You could find something to do with it. But yeah, it is a lot. Admittedly, like you can run like Solana can already handle like a ton of throughput, and you can fit a lot of Solanas, even just on 20 megabytes a second. Like 20 megabytes a second, really, it is a lot, like in terms of throughput, but it's really not that much still.
Compared to where you think we need.
Yeah, you could go way higher. I mean, like in terms of like block propagation by itself is like a lot of other chains have even gone higher. It's not that difficult of a problem. Like it is a difficult problem. It's a fun problem, but I consider it fun because it's so solvable. You can just like go figure it out and do it, and it's fine. And you can replicate blocks globally around the world like extremely quickly. It's like that's fun to do. So anyway, it's a very doable problem, and it's also very doable when you have we have a lot of really good engineers working on core at the moment. The other engineer who's been working on this alongside myself for the past 9 months or so was Rashid. So Rashid is also very cracked. Well, I think he's extremely good at debugging, which is what's required for this release. But sorry, I'm getting very distracted. The main CIP is throughput. That's 20 megabytes, 21.3 megabytes a second. We can probably go a lot higher in the future. Like the current limitation actually isn't the block propagation. We implemented a block propagation and it's way too fast relative to like the other things. Like we made it, like it's actually bad because we optimized in the wrong spots. Because we made it like way too fast. Like it goes at like 100 megabytes a second or something crazy. Like however fast, basically how much bandwidth do you have? That's how fast it will go. It's not like limited by other things at the moment. So that's why we need to now we're focusing not on the block prop, we're focusing on all the other parts. So this is like all the tech debt with Comet and the SDK are great. They were never designed to handle this much throughput, so we're making them. We have to like change a lot of things in order to get them to handle that much throughput. But then besides that CIP, we have that includes the transaction size as well. So now currently, I think you can only submit 2 megabyte blobs, which is actually it's pretty small. And there's not like a super good reason for that besides being conservative. So now we're just being less conservative and going to 8 megabytes. But we'll probably increase it to 32 megabytes very soon as well. Well, at least we will be capable of having 32 megabyte transactions very soon. And then the other CIP is inflation. It's
huge.
Yeah, it's a very sensible, simple change. It's just like, hey, we need to pay the validators so much, but we don't really need to pay the delegators that much. So we will reduce the amount that the delegators get, keep the amount that the validators are getting the same.
Am I right in thinking that this is also sort of a leading down the path towards proof of governance, where we pretty much eliminate almost all of the issuance?
Yeah, I think so. I mean, I actually like to think of those things as separate. But
totally. I mean, but it's sort of
well, you can even have proof of stake with no issuance if you wanted to. You can force token holders to pick you can force them to take a risk. You can force token holders, you can say part of the contract, the social contract of holding the token, is that you have to pick an honest validator set. And if you don't, then social consensus will slash you. And the way around that is that you basically have to you pick a validator set, and then you have these queues. So I wrote about this a while ago, but you can still do this. My definition for proof of stake versus proof of governance is proof of stake is is more permissionless in that you can have the token elect the validator set. So all that's required there is to buy the token. Whereas with proof of governance, you still have token voting, but you have token vetoing. So now the token holders have a veto against a community, against a committee that is, well, presumably it's a committee. I guess it could be, maybe you pick an AI model if you really want to, but I mean, it's a feasible thing. And you can, you have that committee decide the validator sets, and that committee or AI model or whatever is determined by social consensus. By social consensus, I have like a strict definition there, which is like that's embedded in the binary. So who gets to decide the validator set is embedded in the binary. So you still can hard fork. So in theory, it's like just as permissionless. And I don't really know how to describe that actually, but it's complex. You can fork if you wanted to. It's encoded in the binary, meaning it's decided by social consensus. And then you have the token voting who can veto it. So that's really the only difference in my eyes from proof of governance to proof of stake. You could do both. They're both viable. They both kind of end up in like a very similar result, to be honest. Maybe proof of governance might even be like more optimal for decentralization. Like you can just have a flat voting power across all the validators, which is beneficial. So yeah, I'm sorry if I'm going down some rabbit holes, but I see the inflation as very independent, although that is like one of the goals for both, is like lowering the amount of inflation for both. So in theory, I think you could do it. It might be more difficult, and there might be more risks actually with reducing the inflation if you stuck with proof of stake. So by my definition of proof of stake there with the token voting. So maybe, but yeah, the end goal is the same. It's just like you don't need to print all these dang tokens for delegators, and you can almost say like delegators are cucks. Token holders are cucks because it's like you're kind of extracting too much value. That's what I mean by like a cuck here, is like you're taking too much value than you actually produce. Therefore,
that you're providing to the network.
Yeah. It's like you're picking an honest validator set. That's cool. Thank you. But like you don't get to, just because you do a good job doesn't mean you get to extract like this massive amounts of value.
Yeah, I see. Anyway, well, I think we're getting down the proof of governance rabbit hole. We'll have to do another episode all about that. But essentially, I think the important thing for the audience to know is the issuance, which was already reduced by I think 33% in the previous upgrade, is now dropping an additional 50%. So it's now dropping to roughly 2.5% total supply issuance annual, which I think is lower than almost like the majority of other proof of stake networks. And so anyway, I think this is a really big change, along with already what happened before, which is like locking staking rewards and all these other changes to staking that I think will make the economics of the Celestia network better. And it sounds like the proof of governance stuff is still very much an active conversation and is progressing. And you guys can see now why like having people like Evan and John Adler and people like that on the team are always cooking up and thinking, like, honestly, I think ahead of the rest of the industry, like to where things are going and how we can sort of innovate, not just on the, scaling to massive throughput, but also innovate from the perspective of like how to design the economics of these networks to be sustainable, and just to also avoid a lot of the problems with delegation and staking based networks and protocols. So anyway, back to Matcha. So we covered the. Go ahead. What do you?
I was just going to comment. We tend, like people like John, I think, tend to get bored easy. So then they'll get bored and then move on to the next thing, and that's why like John is always thinking about the next thing. So if you find yourself like being bored as like that, you can harness that energy.
Yeah. So anyway, we covered. Well, we should talk a little bit more about the big blocks in a little bit, but massive, like a 16x scale in the block size, huge. 120 megabyte blocks. I saw Guillermo actually commenting about like how many Solanas can fit. And I'll just quickly I just want to share my screen. because I don't know how accurate this is, but can you guys see this down here on this? This is celestiadata.com. They have a cool little dashboard where you can see how many of each network would fit in Celestia's current throughput, which is only 1.3 megabytes per second, or essentially I think we're at 8 megabyte blocks. So if we 16x that, I guess then we could fit what would that be, like 64 Solanas in that amount of throughput, at least at Solana's like current usage. So I just wanted to share that quickly because I think that puts it sort of more in perspective, like the kind of throughput we're talking about. So then we got the big blocks, we got the inflation cutting by half, and then the last one that I think is, there are more CIPs that are wrapped up, but the other big one is removing the token filter. And so what that means is essentially, and you can like explain this probably better than me, but we had enabled TIA-based bridging for IBC and also I think Hyperlane, but only TIA. And now we're making it so that it's possible now to bridge any arbitrary asset through Celestia's bridging, like on IBC or Hyperlane. And so what that means is, like, to me, that's another step forward in terms of the lazy bridging roadmap, where Celestia can be sort of like a routing hub, essentially, and a place for someone to, when they're deploying a new chain, a new application, they can connect there and immediately tap into liquidity from a bunch of other sources, not just other Celestia rollups, but also other networks like Solana and Ethereum. But yeah, maybe explain a bit more about the removing the token filter CIP.
I think you did a great job. You explained it entirely. The code change is actually really small too.
Really?
It's a really small change, and the idea, of course, like you said, it's just like to make it really easy for new chains and chains that want to iterate quickly. So it's like you need some performance of Solana, you need something whatever for your thing, but you're a small team, you don't have a huge BD team to go bridge to every possible thing. It's like, well, now you can just have one bridge, which is more or less standard, and we have like a bunch of examples that you can just connect to. It's permissionless, and then now you can just bridge through that, and it's becoming ZK. I don't think it's Hyperlane currently is not ZK, but we have some very cracked engineers working on the ZK Hyperlane, so that is like it's just a ZK bridge. You don't need to really think about it beyond that, beyond like whether it's Hyperlane or IBC or a smart contract on Ethereum or whatever. It's just like, it's a bridge. It's ZK. It verifies the state machine. It verifies the inclusion to Celestia. And therefore, now if you have a light client that's doing data availability sampling and you're verifying this proof, it's like you don't have to, everything's essentially being verified. So it's like the dream scenario.
Yeah, it kind of, for me, the lazy bridging vision is that the Celestia node software itself kind of does the work of enabling you to verify all these other chains. Like, it's just kind of like baked in at that point. So it kind of extends the functionality, it bundles another functionality into when you're running your rollup and you're running a Celestia node as part of your rollup. Like, you just get all these other things out of the box. Is that kind of how you see it?
Yeah, kind of. I think that's like that's an accurate take, is that you can aggregate bridging.
Mm-hmm. And so the upgrade itself was like very minimal. Why didn't we do it? I guess why didn't we do it before? Like, why did we wait until now if it was such an easy thing to do?
Not only was it an easy change to revert, we went out of our way to prevent this.
Yeah.
We added code to stop using, because IBC by itself supports this, of course, and I don't remember all of the reasoning beforehand, but if I recall correctly, it was, I actually don't remember at all. Beyond it was just like I think the arguments were that rollup shouldn't use it like that. They shouldn't use okay. So initially Celestia didn't have the ZK bridging, it was just IBC. So they didn't. I think the thinking was that rollup shouldn't route through that because it's a committee-based bridging, so you shouldn't use it. But maybe now that we're not having committee-based bridging, it makes more sense to be like, yeah, why not? It's like a very practical solution to bridging. If I can bootstrap my rollup very quickly, with Claude Code or whatever, and have a bridge with all the assets that I need to it, and like before this stream is over, it's like that's actually very powerful.
Absolutely. Yeah, and just so maybe for my own clarification and for the audience too, like what this means is also that not just that Celestia is a place where you route tokens through, but I can actually hold a bridge token on Celestia L1, like in my Celestia L1 account. I'm not limited to only holding TIA. I could have ETH that's bridged in from Ethereum.
Mm-hmm.
Or
you can't do anything with it, but you can.
Yeah, you can't do anything. Yeah, you can't do anything with it, but you can have it.
Yeah, because of course there is no smart contracts on Celestia, so there's nothing.
Yes.
There's nothing fun to do. Only boring stuff.
So okay, a further last question: can someone now mint a coin on Celestia? No. Can I just go and be like, I'm gonna?
You have to mint it on your own rollup.
I see, but what if my rollup? It's just, I don't know. Anyway,
are you trying? You keep like trying to fit it in.
No. I'm just thinking about like, I mean, would it ever make sense for Celestia to be an asset issuance layer as a result of this? And I don't think so, because like it doesn't have that functionality. This doesn't add that functionality.
And like
and that can be like
a token isn't hard. So it's like like bridging is hard. Minting a token is not. Therefore, you should just mint a token on your own rollup if it's your token, or if it's relevant for you, and then you have control over it too as well.
Yeah.
Like you don't need to fork Celestia to go do something. If you wanted to change its state, or change the rules of it, or how it upgrades, or et cetera, like that, like you should handle that on your rollup.
Yeah. Very cool. Okay, so I think are there any other CIPs that are worth sort of talking about? Otherwise, I want to shift gears to talk about sort of like the future roadmap.
We did some stuff to make light clients fast.
Lighter. Oh, right. A lot of like header pruning and things like that. Maybe, go into that. Explain why is that important?
We also just reduced the amount of time that light clients need to sync. Windows. Yeah, exactly. So light clients need to sync, and they need to sample over a period of time. So we just made that period of time smaller. So again, this is another one of those changes where it's like, it's actually pretty small. It's very practical. It has basically only upsides, at least from user perspective on like what they're actually using the chain for. So it seemed like kind of obvious. So again, like another small change that is like I don't want to say one-liner, but in some repos there was like one line of code that you needed to change. Yeah.
And so the point of that is for people tuning in, like light nodes, as Celestia increases the throughput, like the block size gets bigger, the amount of work that light nodes have to do to sample and store, the amount of like data they have to store does grow. It doesn't necessarily grow linearly in all those dimensions, which is part of the scaling superpower of Celestia, but it does mean that there's more work. So it's important to sort of optimize slightly, right?
Yeah, it's
lighter.
It's at the square root of it scales by the square root. Now, that's actually debatable, because I think Nash Q, one of his favorite topics to discuss, you can ping him on X or Twitter or whatever, is that getting rid of the data availability header. So that's where.
Oh, right. Yes.
If you got rid of the data availability, maybe I'm wrong on this, but I'm pretty sure that if you get rid of the data availability header, now you have the normal header, which is constant size, and then now you have the number of samples that you have, which is constant size. So as a light client, then at that point you're not really increasing at all.
Except in the worst case, which is when you have to download a fraud proof, right? Which does.
Oh, very true. Wow, good point.
But luckily, I don't know if Guillermo's still watching. We have ways of potentially getting rid of fraud proofs thanks to Zoda and other moon math.
Yeah, very exciting stuff there.
Yeah,
I would
he's
love
here.
to get rid of fraud proofs because fraud proofs, like the amount of time and effort that we spent, I don't regret it. Like it was a ton. Like in terms of engineering, it was very fun to think about the fraud proofs because it was such a fun puzzle to solve. And John, to John's credit, he's just like genius at these little puzzles. And so with Nash, and they found like these amazing commitment schemes to get all the properties that we want with fraud proofs, and we implemented them, and they're functional today. But then but they still now, like once we solve that puzzle, so now it's no longer fun. Now it's just work. So now I'd much rather prefer to not have the fraud proofs and to do something that and it, not just from an engineering perspective, but also from a very practical UX perspective, is like, oh, well, it's obviously much better if you can have a proof rather than a fraud proof.
Yeah. And Guillermo's chiming me in saying that, well, remember that he's right. The Zoda proofs are, I guess, still relatively large. Like they're one row or column, which I guess is on the same order of magnitude of the original fraud proof. Anyway, let's not rabbit hole in this. We'll talk to Guillermo separately. But while we still have a few more minutes, I want to ask kind of two things, which is one is like, there's this meme going around of like ship Celestia. And I think it kind of just refers to like the engineering culture internally at Celestia, and I guess the speed of sort of like shipping these upgrades. I don't know. Maybe tell us like what is it like from the inside in the engineering team? How is fast paced is the sort of like the work and the progress, and like what does it feel like? And I guess how accurate is this meme of like ship Celestia?
Yeah, it is. We had to build up a lot of tooling and a lot of testing in order to be able to do this, because like the hard part, that the reason why you use Celestia from an engineering point of view is because it handles like a lot of really difficult things for you, such as like high throughput and P2P, like all the P2P stuff, which is like very annoying because the number of edge cases in P2P is insane, because you're connecting to the open internet. Mm-hmm. Anyone can join your network. That's the entire point. And I was like, there's a billion edge cases there that you don't want to have to think about, and that Rashid and I think about all the time. But we built up a lot of tooling to in order to ship faster, because I mean, there's no other way. And then we also have some really neat testing infrastructure. So I love onboarding new engineers to our testing infrastructure, because we built it from scratch after a few iterations. Well, a few iterations were not built from scratch. We built our own, and now it's like amazing, and it can spin up a globally distributed network like within like a minute or two. And it's like hyper realistic. So it's globally distributed, but it's also not even using like Kubernetes. Like a lot of these testing frameworks for P2P stuff use Kubernetes, and they keep everything on one cluster. And then you simulate the bad things that can occur, where we have the real bad things that can occur all the time, like losing a bunch of packets or having a bunch of congestion in like different areas. And like, you can't simulate it properly. That was one of the problems that we were hitting. We're like, okay, if you do like this fake simulation, you just data that's completely far off, and you can't make a decision based on this data. So we had to build that infrastructure, and that's really fun because you spin up like 100 different nodes across the world, and you can go SSH into all of them and like poke around, and then you can see the progress. And it's like one of our other engineers, Nina, described it as being in a cockpit, because you have like so many different things running at once. And then you like have all this information in, and you're trying to like debug what's happening. And because it's so low level, like it like gives you you have root access to all of these machines that are running on like a normal virtual machine. You can it's almost like you have just 100 computers in front of you. Anyway, it's a ton of fun. It's amazing for debugging, and it's really, really good for developing like an understanding of how these systems work IRL. So of course, you have, like the goal is of Celestia is one to give users so they don't have to do that because I enjoy it, but not everyone does. So you have more important things. Users have more important things to focus on in life than spinning up their own testing infrastructure for P2P networks so that they can get realistic results, so that they can design a P2P or even not even design, just debug some crazy thing. And then we also use it's basically required because you have like Comet BFT as well. So we have the state of the art like block propagation, and then you have like Comet BFT, which at the time 10 years ago was definitely state of the art. And then just like other people
10 years ago.
10 years ago. So I don't want to knock it because it's such like a monument of like a achievement. Like it's so cool. But then like it was passed around a few times. So then like it wasn't maybe maintained by the same team over time. So then the cohesive vision for it is like flip-flopping around. Context is lost when it's passed between teams over why something was done in one way or another. So because of that, you have some tech debt, and debugging some of that tech debt when it's like, and like we had to develop all that infrastructure. They didn't have it. So they were making all these decisions about how to design your block prop and all these things without completely blind, just like compounding mistake upon mistake. And the mistakes though, the mistakes, they seem logical. If you think really hard, that's the result that you would get. Unless you actually ran it, and then you would make a different decision because it's not the right mistake. So anyway, that compounds over 10 years. So then like every time you want to debug something, it's can be challenging or fun depending on how you look at it.
I love it. Well, it sounds, that cockpit and the testing environment and sounds like a crypto nerd's sort of like wet dream. So it sounds like you guys are having a lot of fun. And I think that's one of among the many advantages that Celestia has in terms of like how quickly we can ship and iterate on the engineering side, which I truly think, especially with this Matcha upgrade, we're doing things that I think have never really been done before. So that, and just like a super cracked team with you, Rashid, Nina, Renee, Hlib, like the list goes on forever. Anyway, so we're running out of time a little bit here, but I want to just quickly touch on two things. One is, when can people actually expect Matcha to hit mainnet? I know that's not a for sure thing. Obviously, it needs to go through, the whole testnet sort of rigmarole. But what's your expectation of when it's actually going to go live?
I would need to go look at the document that Colin made for our goal time, but I think it's the end of September, or at the latest early October.
And what's the process? Maybe shed some light on the process of how things go from.
Yeah, so we just put it on Arabica, which is a testnet that is not guaranteed to work all the time.
Yeah, it's more internal, right?
Now it has a very.
It's not like everyone should build on Arabica. It's like it's not supposed to be stable.
Every now, like we've had to, I think at one point in time we had to roll back, but it has tremendous uptime, and Selenium, which are god tier Explorer devs, have just had amazing support for it. So like it has a really nice block explorer. Like Selenium is top tier, and it works great, and you can use it if you want. But it will occasionally break. Like I think bridge nodes with the most recent upgrade, I just finished debugging it last night with Renee, and but bridge nodes were broken for a little bit after the upgrade. After we increased the score size. But anyway,
it goes to Arabica and then
to Mocha, which is a much more stable testnet that mimics mainnet. So it has 100 validators. The validators are globally distributed. They're permissionless. They're et cetera. It's a genuinely like very good network. I care a lot about Mocha, despite it being not a real thing. But anyway,
Mocha should have its own token. It should be like Mocha Kusama. Yeah.
I mean, technically, like I've never wanted to say this, but it does have it right now. IBC works
It does
fine.
have
You can go
token.
move it
Oh,
to wherever you want. It's permissionless. Like it's not. It's a real network, and it's very good. Like it's pretty good. Anyway, we're going from Arabica to Mocha and then to mainnet. The Mocha, we're waiting a little bit longer, I think, than we normally would, because there's some API breaking changes, and then there's also like with the block propagation, we want to be really sure that we covered everything, and so that's taking slightly longer. And then we're also increasing the block size in chunks, so we're not going straight from we're at 1.3 to 21.3. We're going from 1.3, I think, to a little over 5, and then to 21.3. But the increases there can be pretty quick, probably like a week or two. I'm not 100% sure. The entire point of doing that is just to leave more room for error. So like if we increase to 5 and we notice that there's some maybe some like minor hiccups, we're pretty confident at this point that it's like pretty stable, knock on wood. But we've tested it a lot. So like the good news is that like if the point of increasing to 5 on Mocha first slowly is so that we will encounter any bugs while also not breaking Mocha. And then going on to mainnet.
Perfect. And so mainnet soon TM, like matter of weeks, not months. And then
end of September, early October.
Awesome, huge. And then my last question is essentially, among these 3 upgrades that we talked about, sort of the 3 major ones, like block size increase, reducing the inflation, adding more bridging functionality. What can we expect? And I think of those as kind of some of the most core 3 things that are on the roadmap. What can we expect sort of in the next upgrade or upgrades on each one of those categories? Just super briefly, like, and you obviously you can't tell say everything. Some of it's probably not public information yet, but I'm just curious if you can like shed some light on what people should be looking forward to.
Yeah, we have in general just IBRL, like reduce bandwidth, reduce latency. It's a based philosophy, and then also the same thing goes for light clients as well. And sorry, light clients are reducing latency, making lighter weight, but not increasing bandwidth. There, of course.
Yes, reduce bandwidth.
The point of light nodes, of course, is to be verifiable, and the throughput size on the throughput side, for even if we want to keep replicating blocks around the world, we're fine. Let's assume that we want to keep doing that. Plenty of headroom. The rest is just like optimizing Comet in the SDK. Might have to do, as always with engineering, it's usually just a little bit more pipelining. It's probably the case here as well. The actual block prop itself is very, very, very fast if we need more throughput. And then for reducing latency, what we might do that in tandem with increasing throughput. So then it's just like, well, we'll just lower block times and keep the block size the same.
Yeah.
And then
so that's on the throughput side, and then on the economic, or is there more stuff on that
throughput side? The proof of governance stuff ongoing discussion, but if I will certainly just like keep reducing inflation. Like the social consensus seems to be that inflation for delegators should keep going down. So if that's the case, then that will just keep happening, and then you naturally end up at either of the 2 scenarios that we discussed before, with proof of stake or proof of governance. And then wait, sorry, what?
And then on the bridging side, I guess, is the last.
Yes, the bridging
category.
Yeah, the bridging we have is really exciting, making tons of progress for the ZK hyperlane. I don't have any ideas on the dates there, but that is definitely coming out soon. And then it's ZK hyperlane. So just a ZK bridge, and then like all the things that you expect on top with bridging, I imagine are also coming. But it would be a disservice to Manav if I try to summarize the changes that are occurring there. You should ping Manav on Twitter.
Yeah. And I just forgot that we didn't mention this, but one of the CIPs, just for the validators out there, is increasing the minimum commission rate for validators. And I think that's pretty important because the point of reducing the issuance is not to like bankrupt validators, even though Evan has previously said
delegators. Delegate. Yeah, of course. Completely agree.
But anyway, I think that validators still need to make like enough money to cover their operating expenses, and so
definitely.
That's one of the things that this covers. I don't know if 10% is going to be enough. Well, I mean, we'll figure it out.
It's the whatever inflation they would have gotten.
It's the same. Yeah, that's true. Whatever reward. Yes, exactly. Yeah.
Whatever their current rate of taking from the inflation that they get, that is doubling. So in some cases, it's happening automatically. So like at the upgrade height, if you're at 5%, it will automatically be converted to 10%. You don't need to touch anything. If it's at 10%, then you will manually need to increase it to 20%, I believe.
Right.
Because it only pushes it up if it's below the new minimum, which is 10%. But in all cases, you just double whatever you need to take because the inflation is being cut in half. Yeah. And hopefully the inflation coming down also makes the inflation that you do get more valuable.
Yes, exactly. And I think that's an important thing. Even a lot of people replied to me when I was sort of sharing my excitement about Matcha on Twitter. Was they were like, oh well, as a staker, I'm really bummed. And I'm like, no, but the thing is, like, this is good for the overall economics of the network, and like, yeah, you won't be earning as much rewards, but it's going to be still a very net positive for you as a token holder, and that's really, I think, what's far more important.
Yeah, currently I think that I don't know what the staking percentage is, but everyone's getting inflated about the same, and then most jurisdictions have taxes on some of this stuff. So then it's like, okay, so if everyone's getting inflated the same and you're getting taxed, you're not actually making any money, as opposed to just not getting any inflation. So we should just stop giving governments free money.
Exactly. That's literally, exactly. It's literally a line item cost of the network that's literally just going to taxes to the government.
Yeah, exactly. What are the governments doing? That's a joke. Sorry.
Anyway, well, Evan, this has been awesome. I'm pumped for Matcha. I really do think this is one of the biggest upgrades that Celestia's had since the 3 years that it's launched. In large part, thanks to you and your team for scaling the block sizes to like a ridiculous level and making it seem, actually keeping us on the track to 1 gigabyte blocks or 1 gigabyte per second throughput. And I'm just really thrilled also to shed some light on the people behind the scenes, like you, who are really the meat and like bones of like Celestia as an organization and as a product and protocol. So hopefully everyone out there, I think we need to do more of this, I think, and like get more of the core engineers like yourself out here talking about what they're doing. Because I find it extremely interesting and cutting edge, and just gets me pumped. So thanks for hopping on. I hope you have a good run. Maybe you do a little show people your toe shoes if you're wearing them.
I'm not wearing my toe shoes right now.
More lore about Evan is the Giga Chad long distance runner, and he wears toe shoes. So
I will definitely go for a long run today. I have my headphones that I always wear. And I'll have my hat, and I'll go get my dog and my toe shoes. And
that's where all your ideas come to you about how to.
For block prop, often I spend a lot of time thinking about. Well,
that's insane. That's so cool. I'm just imagining you like there's like, it should be a meme of like you running, and then like the equations are around your head of like.
Again, I think it comes to the boredom thing again. If you get bored easily, or you let yourself be bored, like on a run. I mean, there's nothing else to do on a run. Then you leave yourself time to think about things that you maybe otherwise wouldn't spend time on. Like no healthy person thinks about block prop that often. You have to like make yourself be bored.
Yeah. I love it. Well, thanks, Evan. Thanks again for coming on. This has been great. Thanks everyone for tuning in. We'll do this again sometime. Look forward to Matcha on mainnet in a few weeks. All right. Take care.
Thanks. You too.